Good morning, welcome to Maths class. Today we will start the new unit area. Today's class will be a little longer. Everyone should cooperate with me. Let us start our class. Before that, I request you to please watch the class very carefully from beginning to end and then do the activities. Okay, look at the picture. Which train is longer? Yes, at glance we can identify this train is longer one. Is it? Then here Ramya has two ribbons. She is trying to find out which one is longer. How do we find out? At glance we cannot identify the longer one. So hold the ribbon side by side, then we can identify the longer one. Okay. Here is a picture of two lines in Ravi's notebook. How do we find out which one is longer? We cannot get them close together to check. Or we cannot tell at a glance like the picture of the train. Then what we do? For identifying the longer line, we must measure these two lines and check it. Okay. Then look at the matchstick rectangles. Here, Jose and Rahim have 16 matchsticks each. All the matchsticks have same length. These are the rectangles made by them with their matchstick. Can you say which one is longer one? Yes, Joe's rectangle is longer one. Here, 7 matchsticks are arranged in lengthwise and 1 matchstick in width or breadthwise. Which is wider? Yes, Rahim's rectangle is wider. Here, 6 matchsticks are in lengthwise and in breadthwise there are 2 matchsticks. By counting the matchstick in lengthwise and breadthwise, we can say which one is longer and which one is wider. Okay, here 2 rectangles are made by using 16 matchsticks. Can we make other rectangles with the 16 matchsticks? Yes. Look, we can also make 2 rectangles by using 16 matchsticks each. Here 5 matchsticks long and 3 matchsticks wide. In this rectangle, 4 matchsticks long and 4 matchsticks wide. Based on the formation of these rectangles by using 16 matchstick, we can fill the table. This is the table. Number of matchstick in lengthwise, number of matchstick in breadthwise, number of matchsticks along the length and breadth. In first rectangle, we can see 7 matchsticks long and 1 matchsticks wide. So 7 matchsticks in lengthwise and 1 matchsticks in breadthwise. In the second rectangle, 6 matchsticks in lengthwise and 2 matchsticks in breadthwise. Then what about the third rectangle? In the third rectangle, yes, 5 matchsticks are in lengthwise and 3 matchsticks are in breadthwise. What about the fourth rectangle? Yes, 4 matchsticks are in lengthwise and 4 matchsticks are in breadthwise. Then can you fill this column? Number of matchsticks along the length and breadth. That means the matchsticks on the adjacent sides. That is 7 plus 1, 8 matchsticks. Here 6 plus 2 is equal to 8. In the case of 4 rectangles, the number of matchsticks on the adjacent sides or the number of matchsticks along the length and breadth is 8. In all these cases, is there any relation between the number of matchsticks along the length and breadth and the total number of matchsticks? Here the total number of matchsticks is 16 and the number of matchsticks along the length and breadth is 8. Is there any relation between 8 and 16? Yes, the number of matchsticks along the length and breadth is half of the total number of matchsticks. That is, half of 16 is 8. In order to understand more, I will give one more example. By using 20 matchsticks, we can make 5 different rectangles. Look at the first rectangle formed by 20 matchsticks. Here 9 matchsticks long and 1 matchsticks wide. Then what about the second rectangle? Here 8 matchsticks long and 2 matchsticks wide. Here in the third rectangle, 7 matchsticks long and 3 matchsticks wide. And in the fourth rectangle, 6 matchsticks long and 4 matchsticks wide. And in the fifth rectangle, 5 matchsticks long and 5 matchsticks wide. So by using 20 matchsticks, we can make 5 different rectangles. Then we can fill the table. By using 20 matchsticks, we can make 5 different rectangles. Now we wrote the number of matchsticks in lengthwise and breadthwise. Then can you say the number of matchsticks along the length and breadthwise? By adding these two numbers, we get the number of matchsticks along the length and breadthwise. Here 9 plus 1 equal to 10. 8 plus 2 is equal to 10. In all these 5 rectangles, the number of matchsticks along the length and breadth is 10. Okay. Here also we can see the relationship between the number of matchsticks along the length and breadth and the total number of matchsticks. Here half of 20 is 10. So we can say that the number of matchsticks along the length and breadth is half of the total number of matchsticks. Okay. By using 10 matchsticks, we can make only 2 rectangles. Here 4 matchsticks long and 1 matchsticks wide. Here 3 matchsticks long and 2 matchsticks wide. By using 10 matchsticks, we can make 2 different rectangles. Now we fill the table. The number of matchsticks along the length and breadthwise is 5. Here also the number of matchsticks along the length and breadth is half of the total number of matchsticks. Then can you tell the way to find out the number of rectangles? By using 16 matchsticks, we can make 4. By using 20, we can make 5. By using 10, we can make 2. How do we find out the number of rectangles in each cases? If the number of matchsticks along the length and breadth is an even number, then the number of different rectangles that can be created is half of the even number. Here 8 is an even number, then half of 8 is 4. So we can make 4 rectangles. In the case of 20 matchsticks, how many rectangles are formed? Here also the number of matchsticks along the length and breadth is an even number. So we take half of this number, that is 10 by 2 is equal to 5. So we can make 5 rectangles by using 20 matchsticks. By using 10 matchsticks, the number of matchsticks along the length and breadth is an odd number. So first we subtract 1 from this number and then take half of that number. That is 5 minus 1 equal 4. Then half of 4 equal to 2. So we can make 2 rectangles. Here we use different matchsticks. In each case, the number of rectangle formed is different. Here we get 4 rectangle, here 5 rectangle, here 2 rectangles are formed. Okay. Squares in rectangle. Do you remember the rectangles made by Jose and Rahim? Yes. Jose split his rectangle into small squares using more matchsticks. We know that Jose made his rectangle by using 7 matchsticks long and 1 matchsticks wide. How many squares are there? Here we can see 7 squares. Okay. What about splitting Rahim's rectangle into squares of same size? We know that Rahim's rectangle is made up of 6 matchsticks long and 2 matchsticks wide. By splitting his rectangle into small squares by using more matchsticks, now we can see 12 small squares. Then what about the third rectangle? Now we can split the third rectangle made up of 20 matchsticks. We know that the third rectangle is made up of 5 matchsticks long and 3 matchsticks wide. Here we can see some squares. How many such squares can we make in this rectangle? Can you draw? Yes. Now, can you tell how many rows or squares can we make? 1, 2, 3. We can make 3 rows of squares. How many squares in one row? In one row, we can see 5 squares. Is it? Then, what is the total number of squares? We know that there are 3 rows. In each row, 5 squares are there. So, the total number of square is equal to 5 into 3, 15. That is 5 into 3 equal 50. Okay. Then, can you split the fourth rectangle into small squares? This is the fourth rectangle made by using 20 matchsticks. We know that 4 matchsticks long and 4 matchsticks wide. Now, we split this rectangle into small squares. Now it can be splitted into small squares. How many rows are there? 1, 2, 3, 4. There are 4 rows. In each row, how many squares? 1, 2, 3, 4. 4 squares are in each row. Then the total number of squares is 4 into 4 equal 16. Then the total number of squares in the fourth rectangle equal to 4 into 4, that is equal to 16. Here we can see 16 small squares. Okay. We split the first rectangle into how many squares? Yes, 7 squares. Then second rectangle is split into how many squares? Yes, 12 squares. Then the third rectangle is split into 15 squares. Then what about the fourth rectangle? Fourth rectangle is split into 16 squares. Can you see any relationship between the number of squares and the number of matchsticks in length and breadth wise? Yes. When we multiply the number of matchsticks in length and breadth wise, we get the number of squares made from these rectangles. That is 7 into 1, that equal to 7. 7 squares can be made out from the first rectangle. Then multiplying the number of matchsticks in length and breadth wise, that is 6 into 2, that is equal 12. That means 12 squares can be made out from the second rectangle, and so on. So all of you fill this column in the table. That is, by using 20 matchsticks, number of squares made out from these rectangle, and by using 10 matchsticks, how many squares can be made out from these rectangles. All of you write it in your notebook. This is the first activity in this chapter. You must draw this table and fill the table properly. Okay. Can you answer this question? That is, how many small squares can we make in a rectangle with 14 matchsticks long and 6 matchsticks wide? That is, lengthwise 14 matchsticks and breadthwise 6 matchsticks. Then how many squares? Yes, 14 into 6. 14 into 6 equal to 84. We can make 84 squares. Next, we move on to the topic paper square. Rani and Veena have a rectangular cardboard pieces. Rani board is 7 cm long and 3 cm wide. Veena's board is 6 cm long and 4 cm wide. From whose cardboard can we cut out more squares of side 1 cm? Can you find out? Yes. From this cardboard we can cut out squares of side 1 cm. Before cutting, we draw squares of side 1 cm. Okay. Suppose this cardboard has length 7 cm and width 3 cm. This is Veena's cardboard. It has length 6 cm and width 4 cm. First we mark the squares of side 1 cm in these two rectangles. Let us do. In this rectangle we can mark 7 squares in one row of side 1 cm each. In this rectangle we can mark 6 squares of side 1 cm each in a row. Let us do. Now look at the Rani's cardboard. In this cardboard, we can mark 7 squares in one row. We can see 3 rows. 1, 2, 3. In each row, there are 7 squares. Then how many squares can be cut out from this Rani's cardboard? Yes, 7 into 3. That is equal to 21 small squares can be cut out from the Rani's cardboard. Now look at the Veena's cardboard. Here we can mark 6 squares of 1 centimeter each in one row. Here how many rows? Yes, 1, 2, 3, 4 rows. In each rows there are 6 small squares. So the total number of squares can be cut out from this cardboard is equal to 6 into 4. That is equal to 24 squares. So we can say that Rani can cut out 21 squares from her cardboard. Veena can cut out 24 squares from her cardboard. So Veena got 3 squares more than Rani. Why did this happen? Because Veena's cardboard has more space within it. So we can cut out more number of squares from Veena's cardboard than Rani's. This is the second activity for you to do in the notebook. Now look at this cardboard which has more space within. At a glance we can say that the red rectangle has more space inside. Then what can you say about the space within 2 10 rupee notes? Yes, the 2 10 rupee notes has same space inside within it. Is it? Then what about if it is a 10 rupee note and a 100 rupee note which has more space within? Here 10 rupee note has less space within it compared to the 100 rupee note. Here Ravi has 2 cardboard pieces. He is trying to find out which cardboard has more space within it. First he placed the cardboard one above the other. But he could not say which one has more space inside because the length and breadth of these 2 cardboard are different. Then what can we do? The only way is that how many squares of same size can be cut out from each cardboard. For that, first we measure the length and width of each cardboard. The green cardboard has length 6 cm, breadth 5 cm. The red cardboard has length 7 cm and breadth 4 cm. Before cutting the squares, first we mark the squares of side 1 cm in each rectangle. Then can you tell how many squares can be drawn in each row? Here 6 cm. So we can draw 6 squares of side 1 cm each. Here the width is 5 cm. So we can draw 5 such rows. So total number of squares can be drawn within the green cardboard is 5 into 6 equal to 13 small squares. Then what about the red rectangle? Here we can draw 7 small squares of side 1 cm each in a row. How many rows can be drawn? Yes. Here 4 such rows can be drawn. Total number of squares equal to 4 into 7, that is equal to 28 small squares. Then can you tell which one has more space within? Yes, green cardboard. Why? From this green board 30 small squares can be cut out. But from the red board only 28 small squares can be cut out. Or we can say that the space inside the red rectangle is equal to the total space within 28 small squares. We say that the area of a square of side 1 cm is 1 square centimeter. That is, the area of square of side 1 cm is 1 square centimeter. This area of each square is 1 square centimeter. 30 such squares can be drawn within this cardboard. Then the total area of this rectangle is 30 square centimeter. Then what about the area of the red rectangle? We know that 28 small square of side 1 centimeter each can be drawn within this cardboard. Each square having area 1 square centimeter. So the total area of this board is equal to 28 square centimeter. Let us conclude that if you know the area, we can identify the larger rectangle. Today's class ends here. You must write the 2 activities in your notebook, and also you simply note the answers of the remaining questions in the textbook itself. Okay, thank you.